So I'll discuss the Kubernetes architecture. What are the different components in the Kubernetes architecture and what each component does. And some of the things you might be hearing, actually most of the things you might be hearing for the first time. While explaining those things, there will be certain words, certain functionalities of Kubernetes which will be used. And I will give you a gist of that functionality, what that functionality does, but we'll cover those in details in its own section because I have section for each functionality. And when I explain in a short, if you don't understand, you can, we can discuss. Okay. So what is Kubernetes? I think you all might have, heard Kubernetes and you might have a good idea. So what Kubernetes does. So if I have to, we'll go through this for definitions, but at the end of the day, it's an orchestration of your images. So you have Docker. Once you run your Docker container with your Docker command only, then so it's just one Docker container you are running, right? If you want to run multiple, then you can't run same container multiple times. Same service has to be deployed on multiple nodes. So it's the same container type on multiple nodes. So Docker command itself won't do it. So Docker Compose can do it, and I think Swarm can do it, and the Kubernetes can do it. Kubernetes is more popular because of its architecture and has more flexibility. And we'll go over this. So it abstracts away the hardware infrastructure, exposes data center as computation resource. So what you put in data center, your virtual machines, and those virtual machines have your, data centers have physical servers, and on physical servers you have virtual machines deployed like Hyperion or things like this. Hyperion or VMware also has something like this which manage your virtual machines. And all those virtual machines, your application is getting deployed. So what Kubernetes does is it exposes that as a resource, like with any software resource. So you can manage that. So microservices architectures use Kubernetes a lot these days. So if these days, if you are developing any microservice, it has to, if it is not containerized, then, make sure it is containerized. And either it uses Docker and Docker Compose, or it will use, Kubernetes. So this is a modern way of developing the microservices. The coding is not going to change. The coding you are still doing in whatever technology you are using, but how do you deploy? How do you, wrap that application? You use, Docker Kubernetes mostly. Now it's a consistent environment for dev, queue, and pod because you saw, right? When we create a Docker image, we give the from and the beginning. Now, what do we give in the from? Like an existing image we have, like a CentOS or something built over CentOS. We use OpenJDK and or Maven JDK or something. So that image is already built, and we are adding our own code over that, or an own configuration or code over that. Now that code, whatever that image is created from there, that image is going to remain same. Whether you run in you can test that image in your dev environment or QA environment or in production environment. So that image is going to remain same, and no one is, so if you have dealt with production issues, you might have encountered scenarios where the people say it's working in QA, why it's not working in production? Because certain memory was different or certain configuration was different. Maybe number of threads were different. I don't know. So some configuration in your code got changed because it is not, in the legacy world, it's not wrapped at an image. Your image is everything. So there is no, so that's why there is no, there are very, still you get some complaints here and there, which Kubernetes can't handle, but more or less the environment specific issue gets taken care. It's easy CI/CD setup because now, it's dealing with images, and images has everything sort of wrapped inside the container and everything. So these are the advantages of Kubernetes. Now what we are going to do is we are going to go to Kubernetes components. Now I have 3-4 diagrams. So same Kubernetes components or same Kubernetes architecture is represented in 3-4 ways. The idea is to the more you go through these diagrams, the more type of diagrams you go through, the more understanding you get, and more clear it becomes. But all will be similar. All 3-4 diagrams will be similar. So what is Kubernetes components? So there are 2 types of Kubernetes components. One is the control plane, and it's called sort of master node or something. And then you have a set of worker nodes, which we call nodes. And in control plane, which is master node, in Kubernetes world, master node is not called master node, it's called control plane always. So you have the API. So this is the API server, which is exposing the APIs of Kubernetes. So we will be running certain commands on Kubernetes using command line, kubectl or something. But those commands internally are invoking this API itself. So whatever you want to do with the cluster resourcing, scheduling, etc., that is taken care. So you have to send that request to API. The second component is scheduler. What scheduler does is scheduling. When we are programmers, sometimes we think scheduling is cron syntax or something. This is not that scheduling. So this scheduling is you ask for a pod, and we'll discuss what pod is. And a pod is basically containers. There's a wrapper above containers, which is called pod, and pod is a Kubernetes terminology. So once you have the pod, and once you ask Kubernetes to have your two containers in pod. So once you have two containers or one container or whatever your architecture is inside a pod, and you tell Kubernetes, now you build this pod for me. Then what Kubernetes will do, it will use a scheduler service. So scheduler will check whatever nodes are having the capability of having the pods deployed on them. So it will create on those. So this is called scheduling. And we'll see what pod is and all those, and scheduling is also, we'll see that. So what Atcd is a sort of thing. It's the cache having key value pair, because Kubernetes stores so much information about you, like pod name. We will be discussing about later about namespaces, labels, and things like this. So it needs some sort of data structure, or what you call where you store the information, right? So Etcd is what it uses. Etcd is an open source also. So Kubernetes uses that in the control plane. Now, what is running on the pod? So you have this, kubelet. So these APIs, when get invoked, they talk to kubelet only. So kubelet is an agent running on the worker nodes. So this agent is, sort of issuing or doing whatever it has been asked by the components in the control panel, and the API is the component which tells it to do whatever, like spin up a pod or things like this. Then QProxy. So whatever you have deployed on your worker nodes, like some pod is deployed, which is running some service, and like our service, whatever service you are dealing with. So it's that service is, might be is running inside the pod, and inside the pod, it's running as a container. Now, and I have a diagram for that. I will show you that in a while. Now that service needs to be invoked. So how do you invoke that service? So the QProxy, so any external commands coming, any external requests coming to access that service go via QProxy, and QProxy implements some rules and everything, and we'll discuss that. So so scheduler we discussed, node we discussed. We'll discuss, so we'll discuss each of these in detail. Controller manager and API server we'll discuss in detail. But let's go to the I have descriptions for each component also separately. Now this is a different diagram. Similar information showed in a different diagram. So so you have control plane. So this control plane is a master node, as I said. It has API server, it has scheduler, it has controller manager, and it has etcd. Then you have worker nodes. Each worker node has a pod. Pod consists of one or more containers. There's a Docker environment, because these images, I will discuss the environment also, because Kubernetes supports more than just Docker as well. But assume these images are in Docker, so there will be a Docker environment, and then kubelet and QProxy. So, and this API server can be invoked from the user interface, from the kubectl, or maybe you can directly you can invoke the API directly also, which generally is not the practice, but that option is also there. And much later in our session we'll discuss how to do that as well. Now moving on. Similar architecture in different way. So you have a control plane, you have worker nodes. So there are many worker nodes. You have in control plane you have API server, which talks to etcd, scheduler, controller manager, kubelet is agent running on worker nodes, QProxy, container runtime. This container runtime. So in the previous screen we showed Docker. Here we are showing container runtime, because Kubernetes, as I said, supports more than just Docker. Similar architecture in a different representation. So I'll skip that because you know that already. Only thing you will mention, you will see that the call to the services, see, where from the external world is coming. Some services deployed on some container inside the worker node. This is a pod, and some container, or maybe these are the pods. I don't know what's trying to represent. So this is a pod, and this is a container, and this container has a service which needs to be accessible, by the external client. So that external client is on the internet, invokes it, goes to QProxy routes it to the proper container. Now we'll go into each of these components. Whatever components we discussed, we'll go into each of these. What is cluster? So you will hear a lot of these terms, cluster and all those things. So what in reality is a cluster? So cluster is, cluster has set of worker machines, which we call nodes, and there has to be minimum one or more nodes. Then, and these are worker nodes, by the way. And these nodes run containerized application by hosting pods, and we'll spend good amount of time discussing what pod is and how do you create and modify and things like this. So pod is a wrapper which can have one or more container. And that happens only in Kubernetes. If you look for some pod concept in only Docker, it won't be there because Docker deals with container directly. Kubernetes deals with container using pod. So nodes run containerized application by hosting pods. So pods have one or more containers. Now control what is this control plane does? It's a master node. So we discussed about the worker nodes. Now this is a master node. So control plane, which is master node, manages nodes and pods. Now, how does it manage nodes and pods? We'll discuss in coming slides. But generally, control plane runs on multiple computers or multiple machines to provide fault tolerance. Right? If it's a master node in reality, if it goes down, then your cluster can go down. So for fault tolerance, it generally it runs on multiple computers. We'll go into the control plane components in little detail. First is control plane. What control plane itself does? So controls the cluster and make it function. So when pod is created, when pod gets destroyed or when the node gets destroyed, what should happen and all those things. Basically, it's responsible for making the cluster work. And it is decision maker for cluster. For example, you have specified that your service is inside the pod. Now, if that pod, and you can say because your service is very popular, so one pod might not be enough. So you say I have this container in my service. My service is inside this container, and I want to have 5 pods. So there will be 5 pods created, and each pod will be having this container. Now, what if one node crashes which had this pod? So then control plane will detect it and immediately start that pod on a new node. Now this control panel, which is the master node, consists of many components. And as we already said, so we are reiterating it here. So the control panel can run on the single node, or it can run on the multiple nodes for high availability and things like this. Control panel has these components: API server, scheduler, controller manager, etcd, and we'll discuss each of these now. So, what is API server? So API server is basically you and other control plane components communicates with. So if I have to communicate to the Kubernetes cluster to spin up a pod or a service or things like this, then I will be interacting. I as a client will be interacting with the API server, whether I'm running kubectl command or UI or something internally. That is interacting with the API only. It exposes Kubernetes API, of course. It is front end of the Kubernetes control plane, and the implementation of API server is a Kube API server. So you can go into this link and read more about this Kube API server. So I will recommend that you go through this, go to this link. If you search for Kube API server on Google, I think this is the first or second link which comes up anyway. So go to this link, it has lot many details. So we will not be covering, all those details here, but to just give an idea that, this is the responsibility of API server. Now, the APIs are exposed using REST endpoints. So ultimately it's a REST endpoint only. It manages ports, services, replication controllers, etc. And we'll discuss each of these in details in coming sessions. A scheduler. So see, we discussed API server now. Now we are on scheduler. So what does scheduler do? So it schedules container across nodes using pods. So it watches newly created pods with no assigned nodes and select nodes for them to run on. So if someone has requested a new pod to be created, so the pod gets created, now it needs nodes where it needs to run on. So that's why scheduler comes into play. So basically, at very high level, what it does, it assigns pods to nodes. So whatever in a pod, I can say, there are 2 containers inside the pod, and run this on, I have 2 replica. So it will start on 2 nodes possibly, and whichever nodes are free, it's a responsibility of scheduler to detect which of these nodes this pods needs to run on. So how does it do that? It is based upon available resources, hardware, software constraints, support needs to a certain memory and all those things. So whatever nodes has it, then it detects it. So it ranks each valid node and binds to the pod to a suitable node. So if there are many nodes, it just keeps ranking, and whatever is higher in the rank, it just assigns it. A kube scheduler is the reference implementation. So maybe like the way we saw, this Kube API server. I forgot to give the link, but you can go and read about the kube scheduler also on the Kubernetes IO documentation. So that's about scheduler. What is controller manager? Sorry. This controller manager, it runs controller process. Now, what are these controller processes? So this is the third component here, you can see, right? So what are the controller processes? So you have, there are many types of controllers. One is the node controller. So node controller is responsible for noticing and responding when node goes down, right? So this is what we said, right? The Kubernetes takes care of node crash or something. So that's a node controller. And these are all part of controller manager. Job controller. So we'll have a job object also in Kubernetes, and we'll discuss what this job object is. Watches for job objects that represent one of tasks. So if you're running some task, background task or something, so then it creates pods to run, those tasks to completion. So then endpoint controller populates the endpoint, object. For example, service, it joins services and pods. So what is pod? Pod we already discussed, right? A pod is having container. So you cannot just deploy only container on the Kubernetes. So container has to be part of the pod. Now this pod needs to be accessible outside. So for that, you create a service object, and we'll discuss in details with example how to create service objects and everything. But for time being, understand that if the pod has to be, see, if the pod exposes REST endpoint, then it has to be accessible outside so that external customers can also use. If pod is only running background job, then of course job controller takes it and run the background job when when it needs to run. But if pod is having the services which needs to be exposed outside, then service object is created, and then it basically joins, binds service to pods or something. So that's called endpoint controller. Service account and token controller create default accounts and API access tokens for new namespaces. See, so we'll discuss what namespaces also. So generally namespaces, like if you have, generally companies have one Kubernetes cluster, and there are different teams, which use the Kubernetes cluster. So each team is assigned certain namespace. That's how even in current company it happens. So each team is assigned namespace. Now, so if you assign each team needs to have its own namespace, then there is some infrastructure thing which needs to happen, right? If it needs to have its own account, it needs to have its own API access token, so that if I am doing something, if I get access to Kubernetes cluster, I should be able to do something only with my services. I should not be able to hit some other services to which I do not have access, or which I should not be accessing, or things like this. So that is taken care by service account and token controllers. There is a cloud manager controller which links the cluster to cloud provider APIs. So see, what we are discussing now is Kubernetes. there are, each cloud provider has, there's a Kubernetes service, there's Azure Kubernetes service, it's called AKS or something. Then AWS has its own Kubernetes service. Google Cloud has its own Kubernetes service. So they do also provide certain functionality. So if you're dealing with the, and we will not be discussing those here because we'll be focusing on the core concepts of Kubernetes. But once you're dealing with the cloud providers, then the controller manager might have a cloud controller manager also. So basically, because whatever you are creating, for example, you are in AWS, you are creating you ask for a new pod. Now that pod has to be a EC2 instance has to be created for that pod. Now, how do you create that EC2 instance? AWS has APIs to create those instances. So maybe cloud controller manager will deal with those APIs and get the EC2 instance created and things like this, and then pod, get the pod deployed or so these are controller. So it also performs cluster level functions like below. So replicating components, tracking worker nodes, handling node failures. So I think we have node failure, worker nodes. When they go down on the crashes, then this controller manager detects it and starts it. If some components need to be replicated, for example, we discussed some some components need to be on high availability or something. So then controller manager is responsible for that. Etcd, we discussed this. It's highly available key value store for all cluster data. So what is this cluster data? You are getting ports, namespaces, labels, jobs, services, and so many other things. Controller manager also might be creating some data. So the ports, their states, their namespaces. So Kubernetes needs some way of storing this. So it's distributed data stores which stores cluster information, and it should be backed up. By default, backing up is not enabled, so you have to back it up. And you can go to this documentation to see to tell. See, you might never need to deal with these components yourself. You will be mostly dealing with the kubectl or your CI/CD process might be dealing with this. So that you might need to understand what is namespace, what is pod, what is service, what is job, and things like this. So and internally Kubernetes, once you tell, and how do you tell Kubernetes will discuss it that I want a pod or service or a job or things like this. So you can tell Kubernetes in certain way and we'll discuss what is that way. But once you tell Kubernetes is what you want, then Kubernetes internally will deal with all this control panel and node and whatever components are on this. Kubernetes internally will deal with that. You might want to, like if you are an admin or something, you might really want to know the Atcd things or the API server or things like this, unless you are invoking API directly, for example. Atcd is a separate open source framework, so you can go into this documentation and you can go to this license also. You can use it outside your Kubernetes implementation as well. Now we'll go to the worker node components. What those components are. So kubelet, right? Each worker node has kubelet. So what kubelet does is an agent running on each worker node. So it monitors containers inside pods if they're running or not running and are healthy. And it talks to the API server and manages container on its node, like even when you have to start the pods, and everything. So kubelet only is invoked. And if they are not running or if they are not healthy, then it talks to the API server. And API server, if let's say something crashes, then kubelet will detect it, and then it will go to the API server. The API server will tell scheduler, and scheduler will schedule it, or things like this. QProxy. It load balances network traffic between application components, maintains network rule on each node. So this is the QProxy and on the each node. So it maintains a network rules on each node. What is network rules? Network rules allow network communication to the pods from inside or outside the cluster. So you can invoke QProxy from inside the cluster also. For example, I have 3 pods and 3 different pods, and pod 1 need to access pod 2 using REST endpoint. So it goes via QProxy. Or pod 2 can be accessed from outside also. So that also goes via QProxy. So user must create a service with the API server to configure the proxy. And we'll discuss how the service needs to be. Service and object. So these pods, services, namespaces, all those are objects. And maybe today, if we get time, we'll discuss, how to create a pod also. So it hides all the pods from the clients. So, clients don't need to know where that pod exists and things like this. So client just need to know this is the service which needs to invoke, and this is a REST endpoint, and it can just invoke it. Intercept requests destined for cluster IP and routes it internally to the service within the node. So you might be on this worker node, there might be many pods running. That's a possibility. So it intercepts the request which is coming and say, okay, this is the request for this service and which is inside this port, so it routes it there. So that's about QProxy. And you can go and read about QProxy in the Kubernetes IO also. It has a lot more information than I'm just representing, but you might not understand all of it. But just go through this and see what all you get from there. Now this is container runtime. So container runtime is a software. So remember in the diagram we see one place Docker and second place container runtime. So container runtime is the software that is responsible for running containers, because ultimately inside the pod you are running containers only. And Kubernetes supports several container runtimes. So Docker is one container runtime. Container D is another container runtime. CRIO is another container runtime. And any implementation of Kubernetes CRI interface. So Kubernetes CRI interface, you can read the documentation from here, which is container runtime interface. You can implement your custom also if you want. And and your the images, Docker images are all these images, Docker container D CRIO adheres to this. So that's why Kubernetes is able to understand and spin up pods containing those containers. Now, how does control panel and node communicate, right? You might not need it initially, but you might need to understand once you set up SSL or something. So you might need to know such information. So node to control panel. Node is worker node. To control panel, to master node. So nodes or pods or nodes communicate or interact with only API server control panel, right? So nodes connect to API service using client certificate. See, these are all REST endpoints. So there is a separate topic I have secrets how this communication works, because if these are SSL based REST endpoints, then there has to be some certificate setup and all those things. But and in the API server needs to know this request is coming from genuine client or something like this. So this is how the communication happens. So for you, if you want to just take away only one thing from here, and that thing you should take away is node talks to the API to the control panel using the API server only. If control panel has to talk to nodes, then API server to kubelet. So it's for fetching logs. So kubelet is the agent we discussed, right? It's running on the worker nodes. So it connects to kubelet for fetching logs, attaching to running pods, and we'll see how to attach to running pods also, etc. Terminate at kubelet HTTP. It terminates at kubelet HTTPS endpoint. Kubelet also has an endpoint. It terminates it there, and after that, it's a local call. Kubernetes will just delegate it to Kubernetes will do kubelet will do whatever that call is asking. So API server to nodes. API server can connect to nodes also. It can connect to ports also, and it can connect services also, like services which we have exposed to which we have written, which needs to be exposed to the outside world. So API server can connect to each of these as well. And this is a reference documentation. You can go and read more about this here. There are various add-ons to Kubernetes cluster. So list of add-ons is here. So let me open one, and you can see there's many of her. And one thing which I was reading is if you want to have some, if you are bugged in any DevOps, if you know about DevOps work, they need to collect some data from your service and put it into some server or something where you can see. And so some of these do this, and some of these have different functionality. But idea is that there are add-ons available, and these are third-party add-ons, not used by Kubernetes. So if you check these add-ons, if anything is needed by you, then you can use this as well. Kubernetes. So now, how running Kubernetes works? So this is probably the last slide here. See what you do, and I have maybe in the subsequent session I have one more diagram which depicts this. So what you do is, so what you all did, what we did last time was So we created an image and put it to image registry. So we use Docker Hub only for image registry, correct? And it just has all the app description and everything. Then this image registry is once you tell this is as part of CI/CD process, or on you might be issuing commands manually also. Now you want to use this image in this image registry, and you using this image, you want to build some pod because you want to test it, you want to do whatever you want, but you need to have your service which is part of this image to be deployed on the Kubernetes cluster. So you issue a command to control panel, and then what control panel will do is control panel will tell kubelet to do something. Then kubelet will connect to so there's a Docker runtime environment. So what happens is once the control panel receives the request, it has to be deployed. The image gets pulled from the image registry, and then it gets deployed on the, see, this is Docker runtime environment, it connects the image registry. So it it pulls that image, creates the port out of that image, and we have seen how this controller manager and all those things work. So and scheduler basically. So once pod is created, then scheduler will allocate those pods to the different nodes. So then so that's how it works. So you can see these are the different services. This is a container image. This is a container image which gets pulled, and then this has, when you have this is multiple containers running inside one pod. This is one pod. This is another pod, and these are multiple containers running. And these pods are built on the images which has come from the image registry only. And when did they come? When when someone, either some automated process, CI/CD, or some user manually issued a command to tell Kubernetes that I want pods for these images to run. And how do you tell images inside the pod? And we'll see that. But there is a way to tell run the pod which uses this image, and you can give replica and all those things. So you issue that command to control panel. It goes to Kubernetes. Docker pull the images and deploys. Then to and fro communication happens. Pod gets created. Scheduler and all those things assign nodes, and all those things happen. So this is how. And I have another detailed diagram, step by step, how this happens. But this is just to give a high level idea that how the image comes from the Docker registry, image registry. It need not be just Docker. It can be any. We discuss what other type of runtime it supports. So it can be any image, but in our case we'll be using Docker image. So from image registry, how image comes and how it gets deployed and everything. So so that's about the Kubernetes architecture. So now we'll discuss Kubernetes ports. So what this port is, how this got created, and things like this. So we'll go into details of ports later, but what we'll do is immediately we'll start a port. We'll create a port, and and then we'll see if the pod is running or not running. So this pod will have the service which we are using. For tips, we have the Spring Boot testing point. So we'll deploy the service inside this pod, and we'll try to access that pod like we did for Docker also. So first of all, you can. So there are multiple ways. You can create a YAML file also. And you can invoke the APIs. We'll be dealing mostly with the YAML files. In the YAML files, you can give the definitions and whatever, etc. So YAML file has the YAML file code for Kubernetes has a standard. So we'll start with the pods, and we'll see what each of these means and what we are specifying. So if you want to know, Kubernetes, this thing, what you should pods, what is the standard for Kubernetes pod? What you should do is, and I have this in the different documentation also. 1 second. Sorry, I made it worse. What I wanted to show was this command. You can say kubectl explain pods. So what it does is, once you explain the pods, it will tell what each syntax.
Sandeep, we have the YAML file option, and what is the other option?
Vandana, can you hold on your question? It's getting recorded. I don't want questions to be recorded. Sure. So hold on to your questions. So so this is so you can do the explain pods. So in pods, it will tell what is this. You have this kind, then this version. What is the description of this? what are the different fields you have, API string, API version, what this API version does, and things like this. You can go through this. But what we'll do now is we'll go through this ourselves. So, so what we are telling is for Kubernetes to create an object, and that object is of type port. And the Kubernetes should use API version. Each API version of for port, might have different, values here, but we'll be using, API version 1 and type of port and some metadata. So in metadata, this is mandatory. We specify the name of the port. This is the name of the port. Then the specification of the port. Now, as we discussed, the port contains containers. So we are specifying the, with the specification. And inside the specification, you saying, what is inside the containers? So we tell containers, and then we say containers consist of image. This is the image name. This is the same image which you have created using Docker command. If you are logged into your, so generally what we'll do is for our testing and practice, we'll be having that image only on our local and we'll be pushing from local. But generally you will be logged into, if you're doing on some testing on your laptop itself. So you might be logged into your Docker repository, image repository, like Docker Hub or something like this. Now, so we are telling, this is the image and version we are giving latest, but you can give any version. Image pull policy is if not present. What is this image pull policy? Image pull policy is that when should Kubernetes pull this image, the name you have given, from the image registry, like Docker Hub or your internal company image registry. You can always say always. So it will always, pull it from the image registry, and you give always when you are using the image, which you have not created, someone else has created. Then you can say always take, from the image registry. But we'll be creating image on our own. And those image, when we create the image using Docker, the image will be on our lab, on our system itself, on our laptop itself. So we don't want it to go to, image registry and pull again and again. So if you remove this, then it will try to go to image registry and pull it. And it takes time. I didn't want to do it, so I said pull from the image registry only when it is not present on the local. If not present, only if it's not present on the local. So that's what image pull policy is. Command. So when the pod is running up, what command I want to give? So this is the command I want to give. I want to run my application. So this also has, this container which uses image also has a name. So I give this name and the port. Hey, people, please go on mute. Now all this is getting recorded and it will be published for everyone in future also. So we are exposing the port 8080 on this container, and how we'll access and all those things. We discuss the service object. So we will not be discussing service object. So we'll be using port forwarding for time being, and maybe in the next session we'll do it. But idea is that the container port, the container port is 8080. Now you have given this specification. Now how do you tell Kubernetes? This is a YAML file. Now how do you tell Kubernetes to run this? So use this command kubectl create -f and give this file name. This specification is stored in this file called create-ports, and it's part of the GitHub repo. You have to ask for access. So this create-ports YAML file is there in that GitHub repo itself. So now once we let me show you. I just ran before this meeting. So let me close this. So so this is the port. So I started my servers and everything, and then whatever ports I had deleted, then when I say kubectl get ports, I don't get any port. Then this is what file I was showing. So create-ports.yaml. So it has API version 1, kind port, metadata is this. Then this is the specification of containers and things like this. There's a liveness clause. Don't worry about this liveness clause. We'll discuss later. Basically, it tells where your service is running. You just keep checking, after these intervals. So we'll come to that when we discuss the liveness clause. But here I am giving this command to run and everything. So then I use this command kubectl create -f create ports YAML. This is a file name, and it says this got created. Now, how would I know it got created? So I issue kubectl get ports. It show me this port and say it's ready and running. Status is running. There has not been restart. If there's any problem in your configuration or image is not available, you will see many restarts happening here. But luckily everything is fine. So it zero restart. Now I want to see the logs. So I can give the kubectl logs, and this is the pod name, right? When you say kubectl get pods, this is your pod name, and this pod name. So I give this pod / pod name, and shows me the logs. Like it would have started, pulled the dependencies and started and everything, right? So it shows me that log. Now what I wanted to do was I wanted to go inside this pod and do something. So I say same like similar thing which we did with Docker, we'll do for Kubernetes also. So kubectl exec -it, and this is the pod name. This is not the container name. This is the pod name, and then give okay, go to bin as such. I could do bash also. So I went inside this. I did bash, and then I gave wrong command, so it exited me out. So but I went again, and the wget was not available. So I used call command. So I went inside this pod again. Ultimately, I'm logging to container only, and then I use the call command. This is the service which we are deployed, right? So I use the call command, and this is the output we got, and so that's it. So that's how we are able to create pod. We are able to create our container inside that pod and be able to access the container and everything. What we'll do in coming session is we might spend little more time on these specifications and this YAML, and there are many extra things which I'm going to this YAML. So we'll be spending significant time on pod YAML only for time being, what else we can do in the pod and what are the other configurations available. So but for today, that is it.